to the second part of our drive with automotive AI. In this video, we will share more about how AI doesn't just assist drivers. It takes the wheel, quite literally, with autonomous vehicles. In our last video, we looked at how cars today are no longer just fire-breathing engines pushing horsepower to their wheels. But through artificial intelligence, they are becoming smart, analytical machines capable of collecting, processing, and acting on the input from a vast array of real-time data collecting sensors. Sensors are each responsible for converting real-world conditions like heat, light, motion, or chemical reactions into electrical signals, which can then be interpreted by machines to do something useful. We looked at radar, LiDAR, cameras, and even ultrasonic sensors, and that AI doesn't just use one sensor's data, it fuses the information collected. AI has the capacity to consume terabytes of complex data in milliseconds, and these sensors feed the car's AI with real-time critical data, just as our senses tell us the radiator is still too hot open. This data is fed into its AI algorithms, often using deep learning models like convolutional neural networks (CNNs) to spot and classify objects, inform behavioral decision-making processes, and make dynamic risk assessments. Through machine learning, AI adapts because it is not just about seeing an object. It's about knowing that object is a pedestrian, a cyclist, or another car. Once the car knows what's around it, AI kicks in again for path planning, something like playing chess with the road. The AI considers every possible move, predicts where objects might go, and plots a course that's safe, efficient, and legal. This involves understanding road rules, traffic patterns, and even social norms, like not cutting off someone who just let you merge. Autonomous vehicles also need to interact with humans on the road and must be capable of interpreting human behavior, like hand signals from a cyclist or the erratic movements of a distracted driver. Not only does AI know how to drive, it must also decide how to drive. Should it slow down for that jaywalker, speed up to catch a green light, or change lanes to avoid a slow-moving vehicle? AI continuously assesses risk. It's not just about avoiding accidents, but minimizing the chance of them happening. If a kid runs into the road, the AI might have already calculated a safe stopping distance or an alternative route. Every mile driven, every interaction adds to its knowledge. Every near miss or traffic jam adds to the car's knowledge base. Through machine learning, the AI system continues to improve over time. The brains of automotive artificial intelligence. We're shifting from cars that react to cars that think, plan, and execute maneuvers with a precision that would make even the best human drivers tip their hats. The brainy bit of self-driving technology does most of the heavy lifting. To do this well, autonomous vehicles utilize a combination of onboard high-speed computer processing and cloud computing finesse. Onboard processing. This is where the rubber meets the road, literally. The car's got to make split-second decisions. A hefty chunk of the AI processing happens right there in the car's central computer. This beast, often called the ECU, Electronic Control Unit, or something fancier like an autonomous driving computer, crunches the data from all those sensors in real time. A genuine supercomputer under your hood. It is continually deciding whether to dodge a pothole or hit the brakes because some jaywalker decided to play real-life Frogger. This onboard system is powerful, quick, and reliable because when you're cruising at highway speeds, you can't wait for a signal from the cloud to tell you to stop. Cloud processing. Now, for the stuff that doesn't need to be instant but is still crucial, we look to the cloud. Here's where the car uploads data via integrated 5G for over-the-air OTA updates for long-term learning, revised maps with the latest construction zones, or even learns from other cars' experiences, like if there's potentially an ice patch up ahead that another car slid on. The cloud is where complex algorithms can chew on vast amounts of data to improve the car's driving algorithms, update software, deliver new autonomous features, or just plan routes with real-time traffic data. The AI in the cloud is always working on making your next ride smoother, safer, and smarter. In essence, this is a tag team of high-performance AI computing power. The car handles the immediate life or death decisions with its onboard AI, while the cloud takes care of the strategy, learning, and updates. This combination gives the car the reflexes of a street racer with the strategic mind of a chess grandmaster. The mechanics of autonomous driving. Let's get down to the nitty-gritty, the real meat and potatoes of how AI actually drives the car down the road. We realize that artificial intelligence is smart, but without hands or feet. How does it control the car? Steering. Enter the world of steer-by-wire systems. Gone are the days of direct mechanical linkage from the steering wheel to the wheels. Now we've got electric motors doing the heavy lifting. When the AI decides it's time to turn, it sends a signal to these motors, which then turn the wheels just like having mechanical robot inside your car's steering column, but way smoother. This setup allows for precise, instant adjustments, making those tight turns or lane changes feel like you're on rails. Braking. Braking in an AI car. That's where brake-by-wire comes into play. Instead of your foot directly pushing a brake pedal that's connected by hydraulics to the brakes, you've got sensors that detect your pedal pressure, or in full autonomy, the AI decides when to brake. This info gets sent to the brake control module, which then applies the brakes electronically. Each wheel can get different levels of braking force thanks to systems like ABS, anti-lock braking system, or ESC, electronic stability control. But now it's all managed by AI for optimal stopping power. Your very own pro racer's foot on your brake, always knowing exactly how much pressure to apply. Throttle. And let's not forget the gas pedal, or in this case, throttle by wire. Again, no direct mechanical connection. Your foot, or the AI's command, goes through sensors to an electronic throttle control system, which then tells the engine, or in EVs, the motor controller, how much power to deliver. It's all about precision control, making sure you get the right amount of juice for the situation, whether you're cruising or need to punch it for an emergency maneuver. It's clear we're not just talking about cars anymore. We're discussing mobile marvels of technology that promise to redefine our relationship with transportation. The capabilities of autonomous vehicles powered by AI extend far beyond the mechanical act of driving. They promise a future where accidents are minimized, traffic flows like a well-orchestrated symphony, and the time spent in transit becomes an opportunity for productivity, relaxation, or creativity. They challenge us to rethink urban planning, environmental impact, and the very fabric of our daily commutes. As we embrace this technology, let us do so with open eyes, ready to steer this revolution towards a horizon where the promise of autonomous driving continues to embrace the thrill of driving, the feel of acceleration, and joy of burning rubber. Leave a comment if you want to learn more about automotive AI and autonomous transportation.